Hello friends, uh, again welcome to our second lecture. This is SDLC model, software development life cycle. In our first lecture we have already seen what is SDLC, what are the different phases in SDLC, and what is STLC, software testing life cycle. So here we are going to see the different models we are having for SDLC. So actually the SDLC models, these are the tools that allow the development team to correctly follow the SDLC steps to create software that meets a business need. So let's go for the first model. So waterfall model. So this is a very basic model and which was very famous. Now also we use, but now it has been replaced by the other models, but still we can see waterfall models. So what is a waterfall model? So in the last lecture what we have seen, the different phases of SDLC, those are nothing but the phases of the waterfall model. So it's a sequential design process in which progress is seen as flowing steadily downwards, similar to the waterfall. So it's a linear approach. So as we can see in this diagram, we are having 7 different phases and it's a linear approach. Means when the requirement analysis will complete, then the system design will start. So there will be some entry and some exit criteria for each and every phase, and on completion of that, next step will start. So it's a sequential phase. It's not like requirement and designing going hand by hand. No. So after the completion of one phase, then the next phase will start. But there are some pitfalls in this model. This model is rigid, simple, but the problem is that here the critical part is the requirement analysis, because for example, if we are in a testing phase and if we find some work which is actually a documentation gap or design gap, now what we can do? Now the changes, for implementing the changes, we again have to go to the first step and we have to again redo the whole process. So it will be as good as the new project itself. So customer is not able to see till the very end of the project. They are not able to validate whether what they are expecting developers have coded that or not. So that is a main pitfall here. So as we discussed, the advantages is it is very simple to use. Management part is also very rigid and easy. Development stages go one by one. So as if you remember, as we have seen in the SDLC life cycle, first the requirements will be gathered. We can go to the previous diagram. So first the requirement will be gathered, and after finalizing the requirements, then the system will design, where developer will come up with the low level design and high level design. After that, implementation, that is when the actual coding will take place, after which testing will happen, then deployment, then maintenance phase will come. A typical SDLC model. So here model is too simple, management is easy, development also goes stage by stage, and it is good for the small and mid-sized project. Now why we are saying the small and mid-sized project? So suppose there is a big project, a project is spanning over 2 years. So in which the majority part is the means development is getting completed by 1.5 years, and after that testing will start. So like if it is such a big project, so starting 3-4 months will be in the requirement gathering, then the design, then the development, then testing will happen, and finally at the end of the testing, then it will go to the prod. And so suppose at that time customer finding some discrepancy, what they have expected, and they it's not aligned to their expectations. So what will happen in such a large project? Most important part is the time. So 2 years are gone, money is gone, so it will be very difficult for the customer to grab the market, because there is a neck cutting competition in everywhere, so we cannot lose the time. So that's why it is good, waterfall model is good for the small or medium sized project. And moreover, it is good when the requirements are very clear. If requirements are continuously changing, waterfall model is not good in that scenario. And moreover, waterfall model can be good if the development team is having experience of doing some similar kind of project. So for example, currently you all might have heard about the UPI, Unified Payment Interface. So every bank is implementing this UPI gateway. So if our company, our developers have already done a UPI product, they can do for the other bank too. They are knowing what is UPI, and they have already implemented that, so they know the technical part also, so it will be easy for them. So there we can go with the waterfall model, where requirements are very clear and we are not having any glitches at technical end too. We are clear that this technology will work, and we are not going to face any glitch there. So these are the disadvantage what we have already discussed. Like for the long-term project, it's inappropriate, especially when there is a high risk. We cannot go with the waterfall model. Another disadvantage is the integration is done at the very end. At the last, the integration, different modules, components will be integrated, and then only we will be able to identify the problems. So use cases is where we can use the waterfall model. So as we discussed, we can use it in a small to mid-level project, and where we are good with the technical stuff and requirements are very clear. Now coming to the V model. So we have seen so many drawbacks in the waterfall model. To overcome that, V model came. So what happens in V model? V stands for the verification and validation. We will see what is verification, what is validation. So it is similar to a waterfall model, but in this they have introduced some extra testing phases. So for each development phase there is a corresponding testing phase. So in the diagram we can see the left side, this left inclined line, it stands for the SDLC, the development cycle, and the right hand side, this part is depicting the testing cycle. So we can see for every development phase there is a corresponding testing phase. So it is also a sequential process. First all the development will happen, requirement gathering, analysis, software design, module design, coding, then the testing will start. So it will go in this sequence. So only difference from the waterfall model is here we are having different testing phases, just to make sure that no defect go to the prod. So here we are having a unit testing. What is unit testing? Unit testing is something which we do at the code level, and mainly it is done by the developer. But in some project we do have a specific unit testing team too, and it is done to eliminate the early stage defects. So when the developer is coding, they test their code before moving it to the sit environment, that is for the testing team. That is nothing but a unit testing. After that comes the integration testing. Integration testing is something like when so we might be having 5 different modules, or we are having 5 different developers. They are developing their their piece of code, and at the end they are going to integrate so that all the modules can interact and communicate with each other, so we can get a final product. So that is a integration testing. So integration is testing when all the modules are linked. After that comes the system testing. So system testing is something when we are testing considering the external systems too. So for example, let's see a banking system. So if we are using a ICICI bank, we are using one user interface to make a payment or see a account details. That is a user interface, that is a digital channel. So that is you can consider one team will be handling that UI part. After that, what will happen when we are submitting a payment? This will go to another system which will convert it into a message form. It will encrypt it. Then it will go to the other system which will be the core banking, which will be the core of the ICICI bank, where all the payments will be processed, and from there it will go to the central bank for the clearing, and likewise. So system testing is when we are testing a system considering the external factors too, like what is the downstream, what is the upstream, how it's going to affect us. That is a system testing. At last comes the acceptance testing. Acceptance testing is done by the UAT team, which mainly consists of the BAs or the stakeholders. Stakeholders in terms, if we are coding for some particular group, say State Bank of India, then the bank people who are having a domain knowledge, who have given the requirement, those people will do the acceptance testing in the client environment, that is in their bank branch, not in the here where the code has been developed, but in the actual place they will do the acceptance testing. Now another thing is this verification and validation. What is verification and what is validation, and how they differ? So verification is something which is static and validation is a dynamic. So verification, it is a kind of a review, a technical review, whether all the requirements have been covered, whether all the mapping documents are in sync with the requirement, like that. So it's a static, it's a verification. Now validation is actually a testing. So when a user is giving some input, whether we are getting the expected output from it or not, that is a validation. So there might be a chance that we have given the verification approval, but we are getting a bug in validation. So in real scenario we do get that. It may happen because developers, they might have understood the requirement correctly, they have coded, but because of some issues in the code, we are getting some error or some wrong output. That is a defect. Again, it might be a chance that different developers, they have understood the requirements in a different way. So again we will get a defect in validation. So this is one more diagram depicting a V model. It is bit in detail. So as we can see, it's the same, but it's in detail. So for coding we are having a unit testing, for LLD design we are having a component testing, for HLD it's a system integration testing, for source requirement specification again a system testing will work, then for the business requirement we are having a acceptance testing. So as we can see, the left line depicting the developer's life cycle and the right side is for the tester's life cycle. Now coming to the advantages and disadvantages for the V model. So V model is very much similar to the waterfall model. Only difference is we have added extra testing phases here just to make sure that no defect goes to the prod. To minimize that probability, we have introduced some extra phases in the testing cycle also. So it is simple, and testing activities like planning, test designing happens well before coding. So it is somewhat similar to the waterfall only. Now disadvantage, as the waterfall model, it's a rigid, and if some changes are coming in the mid of a cycle or at the last of the cycle, then it is difficult to adjust to accommodate those changes. Now where we can use the V model. V model can be used in a small to a medium size project, and again the reason is the same what we have discussed for the waterfall model. Now before going to the other models, here is an interesting study which is a cost versus the phase. So in this diagram you can see here we are seeing a defect, and in the vertical we are seeing the cost. So if some defect is coming up in the requirement phase, then the cost to fix that will be very less, but the same defect when coming in the coding phase, see the cost has been increased by 5 times, and in the component testing or integration part it's a 10 time, in the acceptance testing it's a 15, and if it is going into the prod it's a 30 times. And apart from that, if some defect is going into a prod, then company may have to face a hefty fine too, and they may lose the customers too. So what's the problem with the waterfall or the V model? The problem is that we are getting a final end product at the very end, when all analysis, designing, development, testing will be done. We will be getting a complete polished product at the end. We are getting a polished product, but we don't know, we haven't got a client's approval and their validation, whether is it up to their expectations or not, where what requirement they have given, whether we have understood it correctly or not, that we will be getting to know at the end of the project only. And if by chance, if we have any discrepancy there, or there is any change in the requirement, then cost will be heavy, and apart from that, time factor as we have discussed, that will to play a crucial role here. Sorry. So because of all these drawbacks of the V model and waterfall model, we have a new model which is iterative model. So what is iterative model? Okay, so what is iterative model? So as we can see by the name, so we are not developing a product, the full product in one go. Instead we are dividing it into a smaller cycles, and we are giving the product in small bit and pieces. So what is the advantage here? So we are not going to attempt to start with the full specification. So in the very start we need not have to have the all the requirements and all the specific requirements, and development team can pick some requirements and they can start working on it. So what will happen, that we will be using the sketches and blueprints of the product to the user to get the feedback. So for example, again the big project which is going to be for which we got 2 years of time, we will break it down and we are going to take some requirements of it and we will develop it, and after a month or two we are going back to the client and we will getting a review comments from that, whether we are on the correct path or not. So that is a iterative model, and in a simple analogy you can consider it something like constructing a house. So when we are constructing a house, we don't go for the interiors. The most basic part will be the skeleton. How the house will look, there will be a skeleton. Once we have our pillars, our walls, roofs, then we will go for the minute details about the interiors. So we can compare that to the iterative model. So here as we can see, once we get a requirement, we do a planning, analysis, design will happen, testing will happen, and again evaluation by the client will happen. So based on the feedback, we will again rectify it, we will modify it, and again it will go to evaluation. Finally, when we get a green signal, then it will be deployed, and it will go in pieces, not like the complete project going once live. No. So in other words, what we can say, so as we have taken the ICICI UI example, so we are having so many tabs there, and for that matter, for any banking side, we are having some tabs like accounting, for deposit, for money transfer, for fund transfer. So many tabs are there. So consider that in the first cycle we are developing only the deposits, where user can see what is the amount they are holding. Now in the second cycle we can introduce a fund transfer tab likewise. So we will go in an iterative way, and we will keep rectifying. So in the first, whatever the first deliverable we are giving, if customer is not satisfied, they want some modifications, we will do, and we will again get it evaluated. So it is something like that. This, as we are seeing this requirement, so we have a requirement to paint, to oil this picture. So what we will do in the starting, we will give the skeleton only, we will get it approved, then we will go for the coloring and the final detailing. So the thing is, when we can use the iterative model. So iterative model we can use when requirements we are knowing upfront, but we are expecting it to evolve. Like as I told you, that overall we are knowing the requirement, we understood the requirement completely, but we are expecting minor changes later in the project. And if a project is a very lengthy, it is always good to go by the iterative, like to divide the project and go one by one. And if our technology is new, if our team is working on some new technology, then also it is suggested to go by the iterative model. Now, what are the advantages and disadvantages of the iterative model? So, advantages is we can quickly develop the product. Like, we need not have to have all the detailed requirements in the very start of the project, and the requirement gathering and the development can go in parallel. So one module we have picked, we are having a requirement for that, we will develop, but more modifications can be done in future. So changes we can implement. And another advantage of this is that testing will be done in the small iterations. Like, we are testing only one single module, so it will be easy for the testing team too. Here we are lowering the risk also, and we are supporting the changing requirements. Operating time is also less, and we are getting a customer feedback too, so we can come up with a better product. But disadvantage is we will be requiring more resources here, because our work is iterative. Like, first we are making one model, then we are going to the client and we are asking whether it's as per their expectations or not, and again taking the feedback, then again working on that. So that's why resources, we need more resource, and it will be a costly too. And management attention is also required, because it's a bit complex. Another problem may arise because we are not having all the requirements at the very start of the project. So in the later in the life cycle, when we are getting the remaining requirements, we may face some difficulty. Again, end of the project is not known. So again, like in the waterfall model, we are not getting all the requirements at the very start of the project. That's why end of the project we are not doing, and it can be a risky. Now coming to the incremental model. So incremental model and iterative model is very much similar, but as we are going by the incremental, by the name, how it differs. So here we are developing our modules. We are working on the small pieces. So we are developing one part fully, second part fully, and at last we are integrating. So here we can see by this diagram that we are developing one part, then developing the second part, we are integrating it with the first part, and likewise. So incremental module we can use when we are facing some risk related to funding or the program complexity, or we need to produce something to showcase to the customer very early. But again, we need to know the requirements upfront here also. So as we can see in this diagram, that in the build one we have developed some part, tested that and implemented that. In the build 2 we developed and we integrated with the build 1, and likewise. So again, advantage here is that we are breaking down our work, so it is lowering the cost and error reduction also. It is doing the error reduction because we are not developing the whole project at once, but we are doing it in parts. So for example, we have developed first part, and if we are facing any trouble with it, we will be getting a feedback if there is something wrong, and we can uh, rectify that, and for the coming modules also we can implement that process. The disadvantage here is like when we are developing in bit and pieces, there has to be a good module interface. So if we are developing, if we are breaking a particular product in 5 parts, at the end we need to make sure that when we are combining all 5, they are working as a single product and they are able to communicate. Now something related to iterative and incremental, we are having a prototyping model. So what is a prototype? Prototype we can consider like we all might have visited some building place or some complex or shopping mall. So we might have seen a prototype of that whole society or that shopping mall. We can see a dummy. Yeah, a word will be a dummy. So that is a prototype. So before developing a full product, we will make a dummy kind of thing or a small part of it. Again, it depends on a project to project. Some people call it as a proof of concept too. So proof of concept is something like we are developing a very small part of it. It might be a working, it might not be a working, but mostly it will be a working. We are developing a small part, which will be a small part, and we are presenting it to client, which will showcase that whether our understanding is in sync, what stakeholder have asked or not, or if we need any if we need to rectify it. So once we get the requirements, then we design it, we will make a prototype of it, we will get it evaluated by the customer, and after the review we will update, and again the cycle will go keep on going till we get a green signal from the customer that now they are satisfied with the product. After that we will go for a full development, testing, and then maintenance. So if we see a larger picture how it will looks like here is the phase where we are developing a prototype. Once we get a prototype approval, then we will make a design, coding, and testing. Here we can see it can be a iterative development too. So in the prototype we are developing some small part of the final product, not the full product, but some small part of it to showcase to the customer. Now advantage of it is that in the very early stage we will be getting a feedback of the customer that will ensure a great level of customer satisfaction and comfort, and here new requirements can easily be accommodated. And with the prototype we will also coming to know the missing functionalities, and we will be able to detect error at the very early stage, and thus we will be able to say we are going to save that extra cost, otherwise what would have been incurred when a defect is going in the prod or later in the cycle. And it can be used for the complicated project where the technology is new and our development team is not having a hands-on on that. Then they can produce a prototype, so it will be easy for the developer, which can be reused also. But it's coming to the disadvantage. It's a costly process in terms of time as well as money. In terms of time, because we are keep on going to the customer, we are making a prototype, we are going to the customer, we are taking a feedback, we are modifying our prototype again, and then again going, and this cycle keeps on going until and unless customer is fully satisfied. So it's a costly process, and there may be a chance that there may be a too much variations in the requirement each time the prototype is evaluated by the customer. And here we don't poor documentation due to continuously changing customer requirement can also be a problem. And coming to some real life scenario, after seeing a early prototype, see, customer gave us the requirement, but sometimes it happens that they are also not able to fully imagine the requirements. So after seeing a prototype, they may come up with some missing functionalities, and it will be difficult for the developers to adjust and to accommodate all the changes. Now where we can use a prototype model. So prototype model can be used where we need a lot of interaction with the end user, and for the systems like the online systems, the web interfaces, where the high amount of interaction with end users, prototype model is good to use. Now coming to the spiral model. So what is a spiral model? A spiral model is a combination of a iterative model plus a sequential linear model. So what does it mean? So actually we have seen a waterfall model, a iterative model, and the prototype model also. So it is a mixture of all of these. Let's see a picture of it. Yeah, so in this diagram, as we can see, we are having 4 phases: planning, risk analysis, engineering, and evaluation. We are having 4 phases. So what will happen? First, the requirement will come, a prototype will be made. Here the risk analysis is the most important phase which has been added. So here the prototype we made, that we will get it evaluated by the client, and a risk analysis will also be done. After that, a coding will be done and the final evaluation will be done. So this will like we are having the 4 phases, but each phase is a linear phase. So basically, a spiral model is a risk-driven process model based on the unique risk pattern of a given project. So a spiral model guides the team to adapt elements of one or more process models such as incremental, waterfall, prototyping to eliminate this risk. So as we can see in this cycle, we can see a different spirals. So this spiral is nothing but one iterative cycle. So as we can see, the inner one, the darker one, it is a concept development. So concept development is when we got the requirement and we provide some prototype to the client. So that is a concept development. After that, the second layer, where we did the system development. Now in the third layer we did the system enhancement, then the maintenance. So here each iteration is nothing but, in the spiral model we called it as a spiral. And the difference with other model is here we have introduced a risk analysis phase. So basically a spiral model have 4 phases: the planning phase, the risk analysis phase, engineering, and the evaluation, as we can see here. Again, it's another diagram depicting how the spiral model is made. So this is, in the lower part we can see a waterfall model, and here we can see a prototype model. So when we are combining the two, we are coming up with a spiral model. So here each step is a linear. So when coming to the it's a iterative only, but when we are coming to the analysis or a evaluation, the single individual step, that will go linear. Now coming to our last model, RAD. RAD is a rapid application development process. So it's an adoption of a waterfall model, but what happens here is that we come up with the small targets and the mini projects, and at the end we will combine them all. But it is not only about breaking and integrating them at the end. So main difference here in the rapid application development is we are using some automation tool too to making a process faster. So we can consider it as a component based development, where the mini projects will go in parallel. So team 1, for example, will be making a prototype 1, team 2 will be making a prototype 2, team 3 will be developing a prototype 3, and at last we will be assembling them into a working prototype, a final prototype. So in the RAD model, it is based on the prototyping and iterative development with no specific planning involved. So we need not have to have all the requirements or planning. We do a minimal planning here. We directly stepping into development here. So here we are having a different phases: business modeling, data modeling, process modeling, application generation, and testing. So before business modeling, first of all, we will be communicating to the client, we will getting the requirement, and then will comes the planning, the designing part, then will comes the modeling, then the construction. So what are these different modelings? So first of all, the business model. So for example, if we are coming up with any particular product, so we will be need to have a high level picture of that, what exactly that product is, how it will be communicating. So for example, it's a WhatsApp is a product, we need to develop a WhatsApp product. So what is the basic functionality of it, how the data is flowing at a high level, that will be a business modeling. Then comes the data modeling. So based on the business modeling, we will be grouping the different data sets into the entities. That will make the data modeling, and from data modeling comes the process modeling, where we will be processing the data entities. We are refining the process. And finally, the application generation is nothing but the coding. Then comes the testing and turnover part. So here is another diagram depicting a RAD model. It is somewhat in the diagram we can see similar to the prototype model or iterative model, but main difference here is we are using some automation tool to make it quickly. Now, where we can use a red methodology. Red we can use where the time span is very less, from 60 days to 90 days we need to develop a product, then we will be using a red model. And we are knowing the requirement, and user is very much involved in the life cycle. The stakeholders are involved, and technical risk is also less, and we can modularize the product, so we can break it into different modules. But disadvantage here is that we will be needing the designer and the modeling team. So before going to disadvantage, as we have discussed, advantages: it will reduce the development time, increase the reusability of component, and we will get the reviews from the continuous feedback. We will be getting continuous feedback from the customer. And disadvantages: it depends on a very strong team. We need to have a very strong individual team who will be dedicatedly working for this particular project only. And only this system which we can break down into modules, those can only be designed using a red model, and it requires a highly skilled developers and designers, and it's a costly affair. Okay, so we have seen different models. Here I have listed out, tabulated the difference between them. So mainly it based on the requirements, whether we are getting the requirements, complete requirements in the starting or at the end, or we expecting the changes in that. What is the cost of the project? Is the project small or big? How is the complexity? What expertise we are having, like we are having expertise team to develop that, and the different things like the reusability, user involvement, what is the cost. Depending on all these factors, we can compare the different models. And the important thing is, like each SDLC evolved as a new technology and address the weakness of the old models. So for example, from waterfall model we get a V model, then iterative model came, then prototype model came. So each model, what they are evolving with time, and they are addressing the weakness of the old models. Again, in which project, in which scenario, what model to use, we need to consider many factors. And even in the comparison we can see, and we can identify that in which situation what model we can use. Now coming to the model selection, like what models we need to use. So first of all, it depends on the characteristics of the software to be developed. Whether if it is a short project, we can go for the agile. Okay, so now as I told the agile, I will be making a separate video for the agile because it is a hot cake currently in the market, and I do feel that it requires some good amount of time to go through the agile. So I will make a separate video for the agile. So I am not including the agile model here. I will make a separate video for that. Okay. So characteristics of the software to be developed, whether the project is a complex or if it is a small one, we can go for the agile, or if it is a big one, then we can go for the iterative model likewise. And then the characteristics of the development team. So this is also a very important factor. So if a development team is novice, they are new to the technology, then we can go for the prototyping, because we are not confident on that and they may take time to evolve, so we can go for the prototype type. Now the risk associated with the project. So is it a very high risk project? If yes, we can go for the spiral, where we are having a separate phase, the risk analysis phase only. Then we can go for the for the spiral. Otherwise we can go for the waterfall model too. And finally, the characteristics of the customer, like how much they are going to involve. If they are going to involve, they are fully available, then we can go for the red model, we can go for the agile model. But if their interaction is less, then we can go for the waterfall model. So friends, that's it in this video for the models. We will discuss in our next video, we will discuss about the agile. Till then, goodbye. Thank you.